2.9, if you're wondering what the heck happened to 2.7 and 2.8, 2.7 is on mean, mode, and median, and we're going to do that later. And 2.8 is on finding linear regression, and we're going to do that at the end. So, and so it doesn't go with what we're doing right now. You'll see if you go and look at it, and you're more than welcome to go look at it and do videos on it and everything from the book. And so last thing in chapter 2, and then we'll have some chapter 3 next, right? And then after that we'll have chapter 4, and then after that chapter 5, and then chapter 6, and then chapter all the way to chapter the end, right? The book is long. And so this is graphing inequalities, and it's not so bad at all. The first thing you do is graph the boundary, and that happens at equals. And the good news is that's what we spent all of chapter 2 learning to do, is graph something that has equals. So let's just do that here. So the first step I want to do is I want to graph this. And this is called the boundary. The boundary is like a fence. And so that's going to be my boundary line. And so that's what I want to graph first. It happens at the equals. You can use whatever method that you want to graph this. You can solve this equation for y and use the slope and the y-intercept. Or you can pick points, convenient points, like we did in 2.3 and 2.2. And so, or you can pick the intercepts like we did in 2.4, I think. I might get my sections mixed up, but it's your choice on what you would do, okay? So that means I get the choice because I'm the one doing it, and so you can just compare. No matter what method we use, we should get the same freaking line. So if we don't get the same line, then you know that one of us made a mistake. And so I do pick convenient points. That's my choice. I pick x is 0, and when x is 0, it's usually pretty easy. Y is 1. And it doesn't always a whole number, but it's easy to find. All I have to do is do the division in my head. I usually pick, when it's in standard form like this, I usually pick y is 0. So when y is 0, I cover that up, and x will be 2/5. So it doesn't have to be a whole number to be considered easy. It just wasn't a lot of work. And my last point, my checkpoint, which I always do a checkpoint, is going to be whatever I like but not already in the list. And so I think I might pick 2 for x. So if I do, then the arithmetic, this is going to be 5 times 2 plus 2y equals 2. 10 plus 2y equals 2. Taking away 10 because I'm solving for y. So I do have to do more work than I had to on those other points. That's why they were convenient points, because I didn't have to do very much work. I do it in my head. And so I'm going to get y equals -4. So I'm going to plot these points. 0, 1, 2/5, 0, and 2, 4. Over 2, down 4. 1, 2, 3, 4. And I'm seeing that this point here, 2/5, 0, 2/5, I mean, divide this into 5 equal spots and go over 2 of them. 2/5 is like 0.4, so it's not quite to half. So it's somewhere there. And I can kind of see, oh yeah, you know, other than, it looks pretty good, you know what I mean? It looks like it's going right through all 3 of those points. Now the next thing to do is to notice whether or not you have a solid line for your boundary line or a dashed line for your boundary line. And how you do that, if it's greater than or equal to or less than or equal to, it's solid, meaning that solutions are on the line. And if it's greater than or less than, then it's dashed because the solutions are not on the line. These points are on the line, but they don't solve this inequality because they're not smaller than 2. When you plug them in, they're equal to 2. And so, so ours should be, because of this, should be dashed. So we should draw a dashed line, meaning the points on the line are not part of the solution. It's just the boundary. It's just the fence. So I'm going to get up here Sometimes I accidentally draw a solid line because you get kind of used to doing that, and then find myself having to get my eraser out to make it a dash line. And then the second step, so there's the first step, which is to graph the boundary. That happens at equal. When you have greater than or less than, use a dashed line. When you have greater than or equal to or less than or equal to, use a solid line, which I couldn't make it centered. I don't know why, and I had to give up. Got too tired. And so number 2 is to do a test point. And I usually label my test point TP is what I normally label it. And my test point, I usually choose 0, 0 unless it's on the line. So you can't choose something on the line. But my favorite point to pick for a test point is 0, 0. And I can see that 0, 0 is not on the line. So there's my test point right here, TP. It's on this side of the line. So what you do is you put this in, 5 times 0, that's my test point, 2 times 0 is less than 2. And then you answer the question, is this true or is this false? So 0 is less than 2. It's true. And that means that 0, 0 is a solution. And so the test point, 0, 0, is a solution. And all of the friends on this side of the line are also solutions. They have that in common. All the solutions are on one side of the line. The line is the boundary between solutions and not solutions. So you want to shade the true region. And our true region was where 0, 0 is. Over here would have been the false region. And so that's why you care where your test point is. Your test point cannot be on the line. So if you have a line that includes your test point, choose a different test point. So you get to choose any point you want for your test point. So 0, 0 is a solution. It was the true region. You shade the true region, so you're done. So this is problem 22. 1, 2, buckle my shoe, right? And then we have one more, and then hot diggity dog, right? So the first step is to graph the equals. Y equals 3x plus 2, and that's called the boundary. You can graph this any way you want. You can use the slope and the y-intercept, or you can pick convenient points. You get to choose your favorite method. My favorite method is to pick convenient points. Because the equation is in slope-intercept form, choosing values for x are very convenient and very easy. So 3 times 0 is 0 plus 2. So y is 2. 1. 3 times 1 is 1. 3 times 1 is 3. And 3 plus 2 is 5. All it is arithmetic, right? 2, that's why they're convenient. 6 plus 2 is 8. This one kind of walked off my grid a little bit. And if I want to get another point on the grid, maybe I'll pick -1. 3 times -1 is -3. Plus 2 is -1. So I'm going to plot these points 0, 2, 1, 5, 1, 2, 3, 4, 5, yeah. 2, this is the one that walked off the grid, right? There it is. And -1, -1. But I still have 3 points on the line, and I tell students, make sure that you have 2 on the grid. And if one just walks off, that's okay. But I have 3 on the grid, so I feel really good. Now I have to decide, is it solid or is it dashed, the boundary line? And because of this, it is solid. So I'm going to draw a solid line. And I'm not all done yet, right? The next step when you have inequality, so it's different than having equals, right? When you have inequality is to do a test point. Test point. And my favorite test point is 0, 0. You can choose, your favorite test point could be 10, 10 if you wanted. Your favorite test point could be 1, 6 if you wanted. 1, 6 is right there. can be whatever you wanted for your test point. So here's my test point right there, TP, test point. It's on this side of the line. So I want to see if it's true, and you just put it back in the original inequality. 0 is bigger than 3 times 0 plus 2. 0 is bigger than or equal to 2. And that's not true. So I'm asking myself, is it true or is it false? And this time it is false. And so my test point is in the false region. One side of the line is false and the other side of the line is true. So since I know this is false, I know that this side is true. If I picked a value over here, I would find that it was true. And you want to shade the true side. You want to shade the solution side. And the true side is where your solution is. So this is my true side, and so you want to shade your true side. All of these values, including the values on the line, are part of the solution. So all of these that I've got so lovingly shaded. And so it takes out stress too. Right? And so we did a lovely job on those. One more to do. So I notice it's inequality. They're asking me to graph it. So the first thing that you do is you graph the boundary. And the boundary happens at equals. That's x equals 5. This is the boundary. This is not a slanted line. And so I get to graph it any way I wanted. This is a vertical line. And so when it's slanted, I like to, my choice, pick convenient points. When it's vertical, I like to just go over there and draw it. So you go where x is 5, and you're going to draw your vertical line straight up and down. You want to know, is it solid or is it dashed? And how you know which one it is by this symbol right here. It's solid. And so you draw your solid line. Now, ones that are vertical or horizontal, usually people can just reason out where the shading would be. The shading, the solutions, are smaller than or equal to 5. Well, for the x's, smaller than 5 is this direction. So this is where all my solutions would be. And there's other people that are like, no, I do a test point every time. And so I'm going to do my test point too, and I'm going to show you that you get the same answer. So my favorite point to test, so if I did a test point, I'll give myself a smiley face on if I did a test point on this, because I think I could reason this one out. 0, 0, and it's not on the line. And so you put in, this is x, right? This is y. This equation doesn't have y in it, doesn't care. 0 is smaller than 5. Remember, my test point's right here, test point. It's on this side of the line. There it is, there at 0, 0. And this is true. So my test point is in the true region. So you would shade the true region. And so you get the same. So anyway. Okay, lovely. We did that. We did a good job. It was wonderful.